Thank you for joining us. My name is Layla Medeiros, and on behalf of Cumulus Networks, I'd like to welcome you to our webinar. Today, we'll be discussing network automation for the modern era. This webinar will be run by Matt Peterson, our Director of Customer Engineering at Cumulus Networks. Matt will walk you through some of the best practices when it comes to enabling the automated deployment of Cumulus Linux. The webinar will be about 30 to 45 minutes. At the end of the session, if we have time, we'll take some questions from the participants. For those of you interested, you have the ability to ask questions during the webinar by using the window marked questions. Simply type in your question and click send, and we will try to respond to as many of your questions as possible in real time during the call. But if we don't get to your question during the session, we will make every effort to reply individually after the webinar. And with that, I'd like to turn it over to Matt.
Great. Good morning. Thanks very much for everyone joining us this morning, at least on West Coast time here. Apologies for the audio problems that we're having earlier in the morning here. So we have several topics to cover today. We know that everyone's time is important here, so we'll try to keep this short and sweet as possible and leave the maximum amount of time for Q&A. We're going to start off with a quick recap of Cumulus Linux, talk a little bit about some of the built-in deployment tools, third-party automation suites, with some specific examples, and then finally Q&A. For those of you that are new to Cumulus, or as a quick refresher, Cumulus Linux is a fork of the popular Debian distribution. Essentially, the key differential here is hardware acceleration. Essentially, what that means is that we're translating the kernel networking state to dedicated networking processors. So you're getting the performance of a traditional network switch without being encumbered by the operating system. Also, what this means is that there's no restricted shell or limited access, so it feels just like a Linux server. Cumulus Networks welcomes a variety of applications, so we don't necessarily expect to write them all. We ship a baseline networking functionality, such as BGP, OSPF, LLDP, spanning tree, pseudo, all the sort of regular features you would expect on a modern switching platform. Cumulus Linux has an industry-unique architecture. All of the network functions, such as route entries, firewall rules, these are all hardware accelerated. As you can see in the diagram here, on the right side we have an orange box labeled switched. Essentially what that does is that pushes down data plane configuration to, again, dedicated networking processor chips. So also in this diagram, you'll see that there are some dark green boxes. And essentially what that indicates is software that's written or maintained by Cumulus. And the light green boxes is third-party software. That's obviously software that's not written by Cumulus Networks. So typically that's automation software, monitoring, sometimes overlay software for network virtualization. Network operating systems haven't traditionally been open enough to embrace modern automation techniques or software. So when tools or scripting is available for these legacy platforms, the offering is usually vendor-specific, closed-sourced, or with limited extensibility. So as you can see in the slide here, the typical approach there is screen scraping or using SNMP. That's pretty frustrating, and certainly if you look at modern computing, that's not really the approach for large-scale deployments. Automation software has proven to be indispensable for managing these complex and large-scale compute environments. These automation tools have well-established communities and are generally available under an open license and are highly modular. With the advent of open networking engineers are now empowered to utilize and embrace the same tools as their compute peers. So I want to reiterate that point there, is that these tools, CF Engine, Puppet, Chef, Ansible, these can all be utilized on both Cumulus network switches and on compute platforms. I like to frame this effort as going from the loading dock to production. Automation is just part of a large life cycle of equipment management. This process can be split into 3 different phases. The first of these is system provisioning, such as unboxing the hardware and initial configuration. Second is network provisioning. Typically, this is configuration management, the management interface. It's kind of the first step of getting the device online. And the third is policy enforcement. This too can also combine configuration management. It's typically known for health monitoring, such as monitoring the health of the system or performance, routed entries, etc. So starting with that loading dock to production model, let's begin with the first piece of software that's encountered, ONIE, or ONIE. This is the Open Network Install Environment. Cumulus supported platforms are preloaded with ONIE. This is an open source bootloader originally built by Cumulus engineers. I think we can really consider this essentially Pixie on steroids. It's built to be very modern, and it's flexible enough for a number of management environments. So if you're familiar with OpenWRT, ONIE is very much a stripped down but fully functional Linux operating system. It doesn't have a package management system. It doesn't have every shell under the sun, but it's enough to be very flexible. So the code base was recently adopted by OpenConview project, and it also has very extensive documentation. Now, we're not going to try to cover ONIE in depth entirely today on the webinar, but instead we're going to talk a little bit about some example configurations. So if you already have a Pixie environment for your servers, you're already compatible today. When we look at how ONIE is initiated, there's essentially 3 waterfalls that occur within ONIE. Its entire focus is on these 3 loops. The first one of this is discovery, followed by file transfer, and then finally execution. So first of these loops is really getting onto the network, and this begins on the management Ethernet port, starting with the most modern protocols and ending with a well-known IPv4 address. The second step is to use a file transfer protocol to fetch the operating system installation image. Now, as you can imagine, using something like HTTP is very powerful here, as request headers are sent to the web server, including serial number, MAC address, and other identifying information. Once an image is fetched, it's saved and executed on the switch. So I want to show a few screenshots here that show the progress. Due to some limitations of the webinar software, we decided to show screenshots instead of a live demo. But do trust me, these are cut and paste directly from terminal with minimal modifications here to fit within the window of the slides. So in this first shot here, we're looking at the initial boot of a PowerPC-based switch. So that continues to use U-boot for the initial bring up of the system. So that drives the LEDs and turns on the management Ethernet port, makes the storage available. Very basic sort of BIOS functionality. Because there's no operating system installed on this switch, it automatically goes into ONIE mode. So we can see here that ONIE has been leased an IPv4 address via DHCP, and it's discovered an HTTP URL to fetch an installation image. If we were to look underneath the hood, what that HTTP request looks like on the wire, again, it sends this identifying metadata. And this is extremely powerful in environments where a dynamic system would be set up so that, say, Model A switches get one version of software and Model B switches get a different version of software. With this metadata, you have the power to do that. You typically want it via FTP or even TFTP. Continuing on that ONIE run, the image is saved, extracted, and then a verification process runs. Once verified, the storage is formatted and installation files are transferred to various partitions. An environmental variable is set. Essentially what this does is it signifies that the installation was successful. This means that ONIE won't trigger upon reboot automatically, but instead it's going to load the Cumulus Linux image that was just installed. So starting again from an initial power on here, we see that again U-boot's there for the basic system BIOS functionality, but because Cumulus Linux was installed, it directly boots into Cumulus Linux. And so there's no timeout that has to occur for a network provisioning protocol. Again, if you're familiar with servers that use the Pixie technology, typically they'll have some sort of timeout to discover if there's a Pixie serving functionality on the network and then boot to the operating system. Here we minimize that timeout as much as possible. If we recap this a little bit more graphically instead of from a screenshot or kind of terminal output, I want to present kind of the typical Cumulus Linux installation process. One of the things that's unique about Cumulus Linux is that the installation is intended to be completely unattended. So you can still use the console, syslog, SSH, and other mechanisms to monitor the state of the installation, but our goal is not to utilize a console cable. As mentioned before, the state machine is changed so that ONI knows there's an operating system present, and so it's not going to go into ONI mode, and instead will boot the operating system that was installed. Upon the first boot of Cumulus Linux, ZTP, or zero-touch provisioning, is invoked. Now, all traditional network operating systems have some level of automated initial configuration fetching. This is usually limited towards pushing a well-crafted configuration file. Cumulus Linux takes a different approach, similar to, say, a post kickstart script or an FAI helper script. Now, this implementation closely follows ONI, which we just went over. Essentially, that's fetching a shell script over the management interface and executing. And one of the great benefits of Cumulus Linux is that it ships with several common scripting languages. These are all pre-installed and all available for ZTP scripts to be written against. Now, just as with ONI, the state is preserved. So if a ZTP script fails or it doesn't complete, it will be fetched again on the next system reboot. And obviously, if a script does complete successfully, it's not fetched again. So again, you have that state machine if it should select a provisioning script or not. So let's walk through kind of a complete example here. We'll start off with a DHCP server configuration. So we've specified option 239, or a reserved DHCP option code. When ZTP is triggered, the first boot shell script will be fetched and executed. Just as with ONI, ZTP sends identifying HTTP request headers. Again, this can be utilized in an environment for dynamic script generation. And finally, the first boot script itself. The Cumulus auto-provisioning string is required. So without this string, ZTP can fetch the script, but it won't execute it. So essentially, this is a safety feature to make sure that the script being fetched is geared for the Cumulus Linux environment. So we have kind of a hypothetical example here, and we typically see customers do some level of initial provisioning along these lines. So we're installing Figlet, which is an ASCII art generator program. Then we're setting a switch host name and updating the DNS settings. We're using that Figlet program to change the MOGD, or the message of the day, login banner with some basic ASCII art and a born on date. And then finally, we install the Cumulus Linux license. So without this present, none of the front panel ports will be available for configuration. Again, this is the typical use case for a ZTP, is to at least get the license installed on the platform. So the resulting changes are now presented. Essentially, we've got the login banner available, the born on date, and the license was installed. And this, again, was a very simple bash shell script that really shows the power that can be done with ZTP. Now, there's a lot of common tasks that can be done with ZTP, and it's very powerful. And essentially, it lays the foundations for organizations' specific deployment requirements. So that could be a security requirement, such as changing the authentication. It could even be some initial network configuration. But it's very powerful because all these steps can be done within ZTP. Now, typically, we would recommend that anything that's very expressive would use a configuration or automation tool. And that's what we'll talk about next. Now, before we dive into specific examples of both Puppet and Ansible, I want to briefly talk about automation at a high level. Common in all of the popular automation software suites is this notion of applying policies and responding to the actual versus desired state. Now, every implementation of the software is fairly different. So one may be based off of Ruby or Python. One may be an agent or an agentless model. One may have a custom-defined language. Others may use an existing schema or well-defined language. So they're all a little bit different. And when we compare the open source-based automation tools versus their commercial counterparts, there's a fairly big difference here. One of them really comes with the maturity of the fact that a lot of these projects are very open about bugs and issues, documentations, best practices, and it's really well known how to scale this technology for large-scale deployments. In fact, it's not uncommon to see sysadmin or operation jobs that will actually list the software by name in job postings or requisites. So let's start off with an example with Puppet here. Here we've written a module that installs Cumulus Linux's license file. It does this by checking the presence of the license file. And if it's not found, the file is installed in the correct location, and the switched process is restarted to take effect. Now, as I mentioned before, if the license is not present, none of the front panel ports are available to the operating system. So again, this is a pretty standard use case of using some level of automation software and or a ZTP script to get the system in a usable state. When we look at the syntax of this file, the service, file, and exec syntax essentially represents resource types within the Puppet language. And when Puppet is run with the previously shown module, this is the resulting output. So Puppet is geared for both background and foreground operation. And in this example, we're demonstrating a foreground, very verbose run. It will tell us the success or failure of those defined resource types. Now, a little more of a concrete example besides this license file is in actually configuring some network components. So in this module, we're configuring the etc. network interfaces file. This is the main configuration file for layer 3 definitions of what IP addresses on what interface, link aggregations or bonds, bridges or VLANs. These are all defined in this single file. This module utilizes the Cumulus Networks released NetDev standard lib module. And the link for that module is actually on the slide here. It will also be at the end. So we're defining here a loopback interface along with a bridge that has two members, switch port 30 and switch port 31. Again, if we were to run Puppet in a verbose foreground mode, we can actually see a diff of the lines that are removed or added to this configuration file based on the data fed from the Puppet module. Again, this is run in a verbose mode, but typically these changes would happen behind the scenes, typically as a background crawl job or a reoccurring event. The same management approach of defining a policy and responding to it can also be accomplished with other tools, such as this example with Ansible. And Ansible differs a little bit from Puppet in that the underlying technology is Python instead of Ruby, and modules here are known as playbooks, and these are typically expressed as the YAML file format. So in this playbook, we're installing the Cumulus Linux license again and triggering that switched restart. The command, service, and wait for syntax represents built-in modules available for playbooks. Ansible communicates over SSH to perform actions. Here we see a verbose output of checking the current state, performing a task, and finally reporting on success or failures. Recapping our discussion today, we can see that the modern compute approach to automation and scalability can be very powerful for organizations. Typically, a lot of organizations have struggled to find a cohesive strategy between these two infrastructure pieces. With Cumulus Linux, those same tools can be leveraged across the entire data center. So just as today, no one would drop a CDN to install servers in bulk, why should networking be any different? I think as you can see in the diagram here, what we're trying to convey is that these tools have been utilized for compute environments for decades at this point and are very well understood for scaling that infrastructure. Because Cumulus Linux is an open, unencumbered Linux operating system, again, those same tools, same approaches, same best practices can be applied. I want to give a few examples of additional data available not only on Puppet, including ZTP, but also our friends at Ansible. So here's a few links you can find out more information about. The other thing is that the examples I provided today are available in our GitHub repo or for interactive use in something we call the Cumulus Workbench. The Cumulus Workbench is an environment that's made available to prospective customers that contains switches in various topologies that are already pre-cabled up and ready to go with both management hosts and front panel hosts. This is a great environment to essentially try before you buy and get your hands a little bit excited and wet and dirty with trying all these different things that are possible with scripting. So maybe you're comfortable with Bash today, but you'd like to experiment with Puppet. You can't do that on your production environment. So the Cumulus Workbench is a great place to experiment on that. Again, please don't hesitate to reach out to myself directly or to the organization. I've listed both an email address there and a Twitter account. Now it's time for some questions. So the first one that a lot of folks have asked us is looking at ZTP versus Puppet, and what are the best practices or limitations here? Now, ZTP, as mentioned before, is geared for utilizing the scripting languages that are available in Cumulus Linux today. So those languages are Bash, Ruby, Perl, and Python. And so if you have experience with those languages, it's very powerful. But typically, we would recommend to only use ZTP for initial basic configuration. If you recall, I had some earlier slides that talked about the 3 different phases of deploying network equipment and this automation mindset, again, going from the loading dock to production. And ZTP is a great way to at least get a license key enabled and maybe change some basic settings such as authentication, add an SSH key, etc. But the frameworks like Puppet, Ansible, and their cousins, if you will, CF Engine, Salt, and all the other software that's available there are much more powerful. They have a language that can, again, assess the state of the switch or the operating system current state of configuration files and daemons and can respond to those. And adding that sort of intelligence to a ZTP script could be fairly time-consuming, where these other tools have been written specifically to deal with configuration management. Second tool is basically, do you believe that network engineers will truly embrace automation? And I get asked this question a lot. And I think one of the ways that I look at that is that some vendors today are telling network engineers and customers that all of their team needs to learn how to program. I don't think that's true. I think the analogy that you can look at is a lot of folks drive cars, but we're not all mechanics. And clearly people can cross over between the two. I think the power of these tools is that in most cases, an organization is already utilizing some sort of automation tool. So that could be a commercial tool like Opsware, or it could be an open source tool like Puppet or Ansible. It could be, an implementation that is licensed, something like CF Engine Enterprise. But in any case, those tools are typically utilized on the compute side of the organization. So there's already knowledge there. And I think the power of Cumulus is that you can utilize software that's already in place in your organization and bring it over to the network team or that part of the infrastructure. And that's very powerful. Again, when you've looked at traditional platforms, it's been difficult for the networking team to be able to apply any sort of automation because the languages were not used in the rest of the organization. So something like XSLT or Tickle, those scripting languages didn't get a lot of traction on the compute platform, where these basic scripting languages like Bash, Ruby, Perl, and Python, or Puppet and Ansible, CF Engine, Salt, those sorts of technologies, those have very mass adoption on the compute side. So going back to the original question, again, I don't think that every network engineer needs to learn how to program, but they certainly need to know how to adopt automation technologies that are already in use within their organization. The third are, what are some of these automation tools that Cumulus customers are using today? I think that's a great question. So we see kind of a huge variety of tools being utilized. There's some organizations that have a high level of, say, Bash or Ruby scripting knowledge. So they'll write a large ZTP script, and that's what they're comfortable with. On the open source side, we see a number of tools being utilized. So I would say Puppet, Ansible, CF Engine, we've all seen deployed in production environments. And they each have their kind of strengths and weaknesses. And it's really up to your organization to evaluate what the proper tool is that you're most comfortable with. Some of them have a web interface for reporting and initial configuration. Others are a little bit stronger on just the underlying language that it's written in. So there's different approaches of evaluating that software. In that, at Cumulus Networks, I think one of the great things about the product is that we allow customers their choice of automation tools. Just as customers have their choice of shells and their choice of routing protocols, et cetera, we're not going to push a philosophical, vision, if you would say, to customers that they need to use only X automation software. We're very supportive as best as we can all the popular open source and commercial automation suites.
So actually, Matt, we have a couple of more questions coming in here. So we're just reading them as they come in. One of the questions reads, can I play with some simple configurations of Puppet, Ansible, CF Engine, or other tools with Cumulus Linux?
Yeah, so as mentioned on this slide here, we have two solutions for that. One of them is downloading the examples I showed today on GitHub, and those are available. We've actually packaged those up as Debian deb apt-get packages. And the reason we do that is because our customer workbench environment, we call that the Cumulus workbench, that is based off of both Ubuntu and Debian host. And so when we demonstrate these technologies to customers, we literally provide a bounce host or a management host, and we do a simple apt-get run, and that installs Puppet or Ansible and various topologies and configurations. So we have an example that does, say, IBGP, one that does OSPF, OSPF unnumbered, and various different deployments are available. So the customer workbench is a great platform for, I guess I would say, demonstrating and utilizing these technologies. Again, you don't have to do this in your own environment. You can reserve time in the Cumulus workbench.
Okay, and I think that further to that question, do you have any of these configs to see?
Yeah, so the GitHub example here has a number of the configuration files available for folks to look at. And again, that has both Ansible and Puppet. And those are very, I would say, verbose examples, because we have, again, different topologies available and different examples there of setting user credentials, configuring a routing protocol, adding a license key. They're pretty verbose examples. Again, we just showed a very high-level overview today.
Okay, great. So I think we're out of time now. So thank you, Matt, and thank you, everybody, for your participation. I hope you found the presentation useful. And don't forget to tune in to our next webinar, which will be focused on ONI, and that's scheduled for July 16th. Details will soon be available on our website at www.cumulusnetworks.com. And thanks for your time today, everybody.
Thank you. Cheers.